Okay, perfect. So, Jai Bhim, everyone, and welcome to our next session today. And we will be talking about understanding large language models today. Basically, what we are trying to do in this session is that we'll go back and forth into a lot of links. We'll visit a lot of uh, pages here, as I've said, and I've set it for all of us, and we'll try to see and figure out if we how can we understand more about what's large language models, what makes it large, what is a language model altogether. And while we do that, we will try to understand what this particular thing is. So when we say chat gpt, how does this work? Whenever we ask it a particular question, no matter whatever question we type in here, how can it gives us how can it possibly knows some knowledge, right, which is out there, and how can it gives us back some feedback on any question that we type. It can be literally anything, but we can also ask, like for example, why is the sky blue, and it has some sort of answer, and it will respond to us in a particular way. Oh, in this case it also added uh, the some images, right? So the goal of today's session, um, and I would be very happy to also take questions at the end, but the underlining goal of the session is to know how does this particular thing works, how this particular software or machine, when we ask a particular question, responds to us. And then we want to also know how can we write or prompt this software or this tool in a nicer way when we know how it works altogether. Um, so this will be our goal today, just to understand how this ChatGPT or these large language models work all together, and we will understand how can we write or ask them in a better way. Um, what I think would be really nice is that we can take all of your questions at the end, because I have tried to put everything into a flow, and I know today would be a lot of content new for a lot of audience. Maybe if you are not aware of this, or there will be a lot of people who might get some knowledge, or who might be feeling that this is a repeated knowledge in a way or two. But I'm sure that we all will get to learn something new. And okay, Siddharth, can you please mute this person? All right, I did it. Um, so basically, as I said, the point is to understand what ChatGPT is. The point is to understand how it works. And let's begin. Let's try to understand how large language model works. And here are a few slides. We'll walk through it just so that we maintain a particular sequence and we break through this concept of large language models. When we understand how it works, we'll try to see how can we get it work better. So let me start by saying you that there are a lot of large language models, LLMs. The acronym for this is LLM. Here I have listed actually a few of LLMs. As you could see, that ChatGPT is one that we were inside right now, which is by the company OpenAI. But there is Claude from Anthropic, there is Gemini, there is Grok, there is DeepSeek. So there are a lot of LLMs available right now, where you can ask questions or where you can get your work done in a way or two. And we'll also talk about how that is possible. How can we get our work done in a nicer way? But these are the LLMs that are available out there. In this session throughout, we'll just use three of them, because of course we can't test all of the LLMs, but these three are the major ones, I would say, and these are the ones that I have used very often. So I think I'm pretty good at explaining how I use them, rather. So I think that is what we will try to do today. Um, we can try with chat. We can start. Start with ChatGPT. As I said, our goal is to understand how this particular software works, and then how we can make it work. But after ChatGPT, I'll also introduce Claude, and I will also talk about DeepSeek a little bit here and there. So as you see, we have a lot of companies that offer LLM today. In fact, you can also make one for yourself. We'll also talk about that briefly, and you should get an idea of how it works. But now let's understand what is a large language model and how does it help us? What's happening? So whenever I write a question, how does it know? Is it searching on the internet and writing the answer here? But how does it understand our language? Because every one of us types differently, writes differently, or has a different question altogether. So to understand that, let's understand the behavior of a of let's understand that an artificial intelligence model, AI model, the goal of this model is to predict, right? Is to learn that some knowledge and then to predict. And we'll try to understand it with a simple activity. Um, let's say we have this particular sentence, which is 2 plus 2 equals. So as soon as I said this sentence in a particular sequence where I started with 2 plus 2 equals, you or all of you probably have already got an idea what here would be. And the reason that you guessed this right, I think it's 4, right? That's the common answer that would come up. Uh, and the reason that we have come up with this answer is because we follow this particular sequence of our sentence, and we know the context of this sentence. We know that it's trying to uh, add 2 and 2, and we know that it's 4. Similarly, in this sentence, the cat sat on the. Now I'm not sure exactly on what the cat is set on. It might be sitting on a mat. It might be sitting literally on a lamp, or it can be sitting literally anywhere on your study table, on your food, on your dinner table. It can be sitting anywhere. But there is a chance, and there is a probability that it can be one of this, right? There is a probability. There is a possibility that it can be a mat. There is a possibility that it can also be your study table. So we have some idea there. We loosely know what might come here based on the following sequence. Let's go to this particular sentence. Okay. The weather today is, it can be nice, it can be dull, it can be rainy, it can be anything. But at least we have a particular limited set now. We know what uh, could be coming. So there is a set. It can be either sunny, it can be either rainy, it can be either, uh, you know, dull. So there are chances, right? Let's say these are the answers. Let's say we know there is a set of answers, as I said. So 2 plus 2 equals 1. The answer could be either number 4 or it could be 4. If I am given this particular problem, I feel the answer is more inclined into 4, right? Actually, there could be more possibilities. Like someone could think of something else as well. I don't know. It does not have to be right all the time, right? So for example, let me shorten it down and let's put percentage in form of likelihood. So let's say I believe that there is a chance, I would give it 55 rather. So I say that there is a 55% chance that this is the right answer, the 4, because I see that someone has written 2 in not in a numerical form, but literally in a they have spelled it out. Also, in this case, 2 is spelled out. So I think the answer is also spelled out. So it's 4. But there is also a chance that the answer could be, let me give a probability of likelihood to this number as well. So I would say it could also be, let's say 35%. Someone could really write down the number. But as you see the full stops, we can give it remaining. Okay, right? Let's call it the residuals. The whatever is remaining, we give it that percentage, right? So I can clearly see that the answer here is 4 in this case, because this is what is the most likelihood to happen. So there is a 55% chance that 2 plus 2 equals 4 in our language and in our sentence and in our understanding, right? Similarly, I can't really assign properly in this case. I'm not sure which one would be the right thing. I don't know if I should give 55% to this. It doesn't make sense to me. I can also give it 10, uh, maybe 10%, or maybe 5. I think this is more likelihood to me, to I'll give it 15%. So the point here is that in this case, I really don't understand. In this case, it was slightly easy for me to figure out that there is a 55% likelihood that, and the higher probability is that someone might be, the prediction or the thing that really goes here is 4. But here I'm not sure. Similarly, here I'm not sure. I'm not sure if it's sunny, gloomy, warm, or whatever, right? But let's move to this question so that we understand how can we be more and more sure about what would be the next word in this particular sentence, right? So let's say if I get more context, let's say if I know what you are talking even before this sentence. So in this case, let's say we have a sentence before this. So the sentence before this is, at last, the summer is here. So it feels like someone is really tired of winter already. And they are saying that, oh my God, after winter and after all the dull days, at last the summer is here. So I get that feeling. And now the next sentence, which is after this, is the weather today is, okay, sorry, the weather today is, now I can give a likelihood score more better. Let me actually take back these scores from here so that we can likelihood give it. So let's say I feel now that the next word, there is a high likelihood that the next word is either sunny or warm. I feel that it's going to be warm. So let's say I'll give this 34%. I give this really 30%. And there is no chance that it would be gloomy. There is a very less chance. Obviously, there is a probability to everything. That's what we learn in physics. We learn that a lot of models are stochastic in nature, and it is which means that there are likelihood or there is a probability for a lot to for different things to express themselves, right? But I don't think that the person here or the the language here is trying to say us that it is going to be gloomy. So I'm going to give it very less. I'll give it just 8 or even less than 8%, actually 2%. And the rest of it, we will give it to the dot dot dot, right? We don't know. So the point here is that we were successfully able to predict what would be the next word. Uh, all right, I have to mute an individual. So we were successfully able to were able to predict uh, what comes after this particular sentence based on the context that we had in the past, right? So let me say you this that this is exactly what an LLM model is learning. What an LLM model does is that it takes it understands your sentences, it understands the background, and it tries to predict what comes next in the sentence. It tries to learn what how our language is tailored, how our language is made, and then it tries to predict what comes next in our language. This is exactly what LLM is doing. But LLM is not using the words the way we are using, but LLM uses something called as tokens. So let me explain you what does a token means here. Where did the tokenizer go? I actually had a tokenizer somewhere here. Hmm. Okay, let's search for a tokenizer, right? And then we'll come back to this. Okay, maybe there is a tokenizer here. Okay, so let's say we have this particular question. So what actually happens is that when you write this question, so how, as I said, we follow the sentences, but LLMs not necessarily work around the words like we do. But what the LLM does is that it represents these words into certain digits, and these digits are called tokens. So this sentence is represented as you see in 7 tokens, 1, 2, 3, and so, around 26 characters. And yeah, these 26 characters are represented in 7 tokens. And this is how the tokens look like. So this is what the LLM will uh, get out of this sentence. And as you see, the the really the capitalization of these characters also matter. For example, the is 3086, but capital D, the is 623. So basically, we have assigned numbers to each word and the structure that they have laid out. And that's how we try to capture the sentence. So what LLM is trying to see and learn is that when you have a particular sequence of tokens like this, when you have numbers in this particular pattern, and when you have another numbers in this particular pattern, there is a likelihood that it would be sunny or warm as an answer. And then it would predict this as a token. We are using tokens for a lot of reasons. Why don't we directly use words? Because, of course, it's nice to tune and play around prediction of numbers because that's where our probability is pretty easy to understand. But the point is, we are not really doing any math with these particular tokens, but we are just tokenizing all our language and its variations with different numbers. For example, I could say something in a certain way when I'm being sarcastic, but when I'm being serious, I could say the same thing in a more different way. But how do one understands that? One can emphasize that with the characters, the way you write it, the way you have added a question mark at the end. You know, so there are ways that we want our model to learn. Also, our expressions and our ideas that we capture inside the sentences, and that's why we give uh, numbers to these sentences, which are basically tokens in this case. So coming back to our slides. As I said, LLM is doing nothing but something similar to what we just practiced. We practiced following a sentence. We practiced actually predicting the next word in the sentence, but we realized that it's not really that helpful. But if we get more context, then it becomes slightly more easy for us to predict. In this case, I could say it's warm. I'm pretty confident that it would be warm, right? But LLM does the same thing, but it embeds all our words into numbers so that it can capture a lot of nuances and differences that we write different things together. So this is what LLM is doing. All right. So the key point that we have learned so far is that the LLM uh, learns from the data. You don't have to go through this slide right now, but the key point we have learned is that the LLM model tries to predict next word in the sentence, right? And in doing so, it eventually gains a lot of knowledge of our language and how we tailor and how we structure our language. So that is the plus point that it eventually gains. It basically just by predicting the next word, it figures out some patterns in our language, it figures out some facts, and it figures out some reasoning styles and much more things, basically. So, what is the data that these models are trained on? So, I have also discussed this in our previous session. So, uh, it looks something like this. So here is an example. So this particular website, the Fine Web Data, which is actually created by Hugging Face firm, let's say. So what they are talking here about is that they have recorded a the huge data set that is available on internet. Basically, a lot of internet pages which are of good quality. So they're trying to record the data of all these internet pages. And here they say that they have about 44 TB of disk data available. Here you can see how they collected the data. And when you read through this, you will understand that they have a lot of text data. So basically, what is happening here is that your model is being trained on all of this data. And it is trained just to predict the next word, which we just did in this particular right? In this particular exercise, what we did is we predicted the next word based on the certain context. So here the model is fed this huge uh, internet data. In case of ChatGPT, of course, they have their own data set. But for you to explore uh, something of your own, for you to check the existing data set, you can definitely go through this website and understand how the LLMs are trained and what type of data set is there. The point here is that now we know that uh, LLM is trying to predict the next word, but the sentences and the data that we have given it to learn that is literally complete internet, or mostly the internet part of it. Okay, if you know, yeah, all right, mostly the internet part of it. Um, and eventually it learns patterns, facts, and reasoning styles, as I said. So that's why I see the LLM something like this. So whenever I imagine an LLM, whenever I imagine ChatGPT, I imagine this image. I see that it's just a chatting machine which has internet data, lossy zipped internet data, maybe about 1000 GB, let's say, or more than that. So why I call it lossy? Because it's really a little lossy because it's not exactly trying to learn or remember the data, but it is just trying to learn the next word, right? Or predict the next word. But while it tries to do that, it eventually learns a lot of knowledge. But this is not one-on-one knowledge. This is not a direct knowledge that you ask for something and you're just going to get that thing altogether, because it's not a memory space, but it is just trying to learn your patterns out of our data. And while it does that, it tries to capture a lot of knowledge. Um, we talked about what happens with these tokens. We talked about how LLMs work. So LLMs convert our words and sentences into tokens to get more and more clarity into how these words are expressed. So what really happens is that these tokens then go inside this particular structure. So this is what an LLM looks like. In this case, we are talking about a nano GPT, which is pretty small compared to the big GPT. So here are other models as well. Here is a GPT-3 model, and here you can see how it looks like. It's huge, actually. For those who know, our goal today is not to really find out how this works, but we just can see it pretty clearly that what is the input to this? So the input to this is tokens. So these things that we just talked about, these particular tokens, are going inside this. There is a lot of math and a lot of tuning happening inside all of this. As you can see, there is some addition going on, then there are some vector multiplications going on, and a lot of things are going on. But eventually, it also outputs a token, which you can see here. So the input is tokens, which is nothing but embedding of our language, and the output is also tokens, right? So when the model does this over the complete data of internet that is available to it, I, ideally high quality data, then the model tries to find and learn patterns inside our languages, and that is what really the LLM is. But the problem now is that if you make a model just to predict the next word, which we are really doing, we are really teaching LLM, which is just a token tumbler in this case, that here are the tokens, predict what's the next token, right? Predict what's the next word. But when you do that to a model, where the model learns, definitely the model has learned a lot. The model has learned about your internet. The model has learned about the language patterns that we have and some facts while it does that. But the problem here is how can you use such a model as an assistant? Because right now the model is just predicting the next word. How can you use it as an assistant? How can you ask it a question and it has to respond to you? Because if I ask a question to a model, such model, then the model will just predict the next word. And the model will not at all try to really communicate with me, right? So for that, we do something called as post-training, right? So right now we were in pre-training. In pre-training, as I said, we give model the complete internet data and we just want it to predict the next word. We want it to figure out the pattern and we want it to learn the next word based on the context that we have fed it. And while it does that, it learns a lot of language from the internet, which we talked about. Um, but after we have done training, which is pre-training, we have something called as post-training, which is afterwards training. So now, just to mention, just to highlight that, like pre-training, as we said, uses a lot of data, and we really want our model to predict the next word. As we said in the past, that there is a likelihood it's a stochastic problem because there are likelihood that the next word could be anything. In case of cat, the cat might be sitting on a pole, it might be sitting on a table, it can also be sitting on a mat. So we assign a lot of likelihood to the output, and because of that, we really need a strong, robust model that goes through all the internet data and learns from it. Not once, but multiple times in multiple epochs. You don't teach your child just once a particular thing. For example, if a child sees an apple, you just don't say them that it's an apple just once. You have to teach it multiple times. You have to say it in multiple ways. Ah, that's an apple. Oh no, that's a mango. So you have to also kind of train it to recognize an apple. Similarly, in this case, you have to train this model on the huge machine learning data. All right, on the huge machine learning data, so that it could really uh, guess nicely what is coming in the next as the next word. So that's why pre-training is pretty costly because right now we are using the huge data. So of course, high data collection is required, which is the internet data, and we require hardware to train this. We require handling and cleaning of this huge data, the internet data, and we have to run and use this hardware for months at sometimes. And that's why pre-training, which we just talked about, which is just guessing the next word, but trained on the internet data, is really expensive. And that's why it does not happen often. Something that is expensive, why? And Exactly. So the price that you could guess is something around $10 million to pre-train a model in such scenario. So that's why it's pretty expensive, and that is the reason not a lot of companies do it very often. And that's why when you come to ChatGPT, let's ask ChatGPT. So we can say, when was this model pre-trained, right? Uh, let's see what it has to say. The model currently talking about is GPT 5.3. All right, I see it's 5.3, and I used an instant mode because I want a quick answer. I can't wait for the GPT because we are in the session right now, so it's better to have a quick answer. So I used an instance from this drop
Can
down.
you increase font size?
All right, yes. Okay, I hope you can see now. So basically, I used an instant model because I want a quick answer. And I typed the simple question, which is, when was this model pre-trained? Since we are talking about pre-training. And the answer to me was that the model, this particular family of the model, was trained on August 2025. So basically, it's trained on the data until August 2025. So after August 2025, it should not have any idea of what's happening in the world. So right now, this particular model has no idea that there are tensions between going on between a few nations, which we know, which we see in the news. But this model does not have any idea about it. And why is that so? Because pre-training is expensive. So not everyone does it often. You do it twice a year, maybe. And this was done last year. All right. And this was done last year. And maybe that's why it doesn't really have knowledge of the current scenario that's happening. So in this case, so now we know about pre-training. But as I said, what do we now do? How can we create our model as an assistant that can help us? So we do that by something called as post-training, which is after the training. So here you try to make or teach the model the persona of an assistant to reply a human being, basically. So here you teach, or here you feed a model with more data, which is mostly human made or human tailored. And you teach model that whenever there is a question in so and so pattern, I don't know if we can use this tokenizer to show that but basically what's happening is that whenever you ask a question, uh, why is the sky blue, for example. So whenever the model sees this particular token, okay, so this is the token for y, 13903 in this case shows y, which starts with a capital W. So it knows now that this is the start of the sentence. So whenever I see a sequence like this, I have to answer in a certain way. So that is why the model reacts with, that's a great question, usually, right? A lot of times ChatGPT has this particular first sentence. So it reacts with, that's a great question. I want to erase this so that you know. So it reacts with this standard tokens. And then it tries to fabricate whatever your question was, or it tries to kind of answer your question in a way that it was fine-tuned after it was trained. So okay, sorry for that. So that is what really is happening. So post training is just training your model on conversations uh, of humans and like a like an individual and an assistant, so that the model really knows how to talk to a human being. That's why when I asked this previous model a question, it really answered that, oh, that's a great question. The sky is blue because of Rayleigh scattering, and so and so and so forth. Um, so this is what was done at post training. And the post training, since it's not a huge data set, it's just supervising and fine tuning your model to act like a personal assistant, let's say. That's why it's not that expensive, it's cheaper, and that's why it's done pretty often. So post training is something that you can do at low cost, and that's why a lot of companies do it often. And this is where I see that our loosely zipped internet data, about 1000 GB in this case, um, is now converted into an assistant after post training, right? So our lossy zipped internet data is now an assistant, and we can of course ask it questions and then get our answers back. So this is what happens after post training. Before I go to the next, how to use these models, now that we have understood what is pre training, what is post training, before we go into how can we use these models, I want to really talk about some interesting properties that happen while we train these models. Um, One thing is that, and there are many others, by the way, and I have just listed three of them here because these are the most interesting to me, and I think it would be very interesting to you to know that. So whenever we are training an LLM model, like we talked about, the model is trying to predict the next word, and then we also use some fine tuning to make this an assistant. There are some new things that emerge. There are some new problems that emerge in in the behavior of this model. So one problem could be, or one interesting property, I would say rather, could be hallucination. So what actually happens is that model predicts, because as we said, that the model is just trying to predict the next word. It has been trained in that particular fashion. And the next word is really, there is a probability that it can be any of this, right? But the model is just relying on the most likelihood, the most probable thing that could happen in its sentence structure. That's why it also often does a lot of mistakes. Often the model hallucinates, which means it believes that an answer is true, but it is factually wrong. So, because it's again a token tumbler, which just predicts the next token. So, not always the prediction or the context is understood right, or the prediction goes the way we want, right? So, there are also places where the model hallucinates. So, you don't have to completely rely on what, not at all, because we now know that it's just a token tumbler. It's just predicting what the next word is. That is how it is trained on. So it is not really trained to, in a different way, to just talk about facts, right? But it is trained on the internet data just to figure out what the pattern is and what the next word could be. So what is the context in this case? And it is a lossy packed internet data. So it gives you all the internet knowledge based on what you have said it to do, and it just predicts the next word, and based on that it tailor makes, or it creates an answer or a response to your question. And it hallucinates. It predicts plausible sounding solution, but the solution is factually wrong, and that is when we call it hallucination. Very interestingly, when you teach the model to uh, let's say, okay, now we come to the second property, which is one of my favorite ones, and I'm very excited to share this with you. It's because right now we were trying to teach our model just to predict the next word, right? But so there was an input that we gave to the model. So the input in this case was as the same question. Let's go back to the same question. Why is the sky blue? Right. So we gave the model this input. So the model has received these tokens, right? The model is looking at this and it just finds similar token, predicts the next word, and tailor makes our answers. But sometimes, the questions are very deep, or sometimes the question require thinking. So what additionally you can do in the fine tuning phase, which is after the training of the model, is that you can teach somehow the model to, uh, or you can train the model on top of uh, mathematical data or mathematical solutions or scientific thinking data, let's say, like, and scientific approach data, where the model will learn to break down a problem into bunch of chunks. Let's say you have a big problem, but how we humans tackle a big problem is that we think about that problem and then we think about breaking it down into chunks. So this is what was demonstrated first into this particular paper, which is DeepSeek R1, this particular paper by the DeepSeek group. DeepSeek is one of the LLMs which we'll also talk about, and I'll also show you quickly in our session today. But what's really interesting is that in this paper, when you go to this particular plot, they are trying to say that, of course, the accuracy of the answer of the model is increasing, but they are trying to say that it's increasing when the length of response has increased. So if the model has realized to give more bigger responses, when the model realizes that I want to give bigger responses to a particular question, the accuracy somehow suddenly increases. And why is that happening is because the model learns, for example, if you ask it a difficult question, if A is greater than 1, then the sum of so and so, what will it be? So the model can't directly give you an answer of this because the job of this model is just to predict the next word. But when you teach it in a certain way, which is described in this paper, and I don't want to go into that detail. But when you fine tune it in a certain way, the model learns to break this problem into different separate problems. So the model says that, okay, to solve this, let's start by squaring both sides. Let's first do this. Let's then do that. So what the model is really doing is that the tokens that I give it, it extends that token set. So it makes more token out of my question. And that is how, okay, there's some audio going on.
Pradil, can you make me the co-host? I will moderate that.
Okay, you are the co-host now. All right. Um, Sorry for that. Please mute your microphones, and I'll take all the questions at the end. We don't want to break the flow. So basically, what the point is that when you give a question to such a model that has thinking capacity, it makes your question bigger. It breaks your question into a bunch of new tokens because it has figured out now a way to kind of first solve the problem into different chunks, which is even nice because how much can a model do in just one complete pass, right? Because it has to break the tokens into a bunch of other tokens. Let me come back to this. Yes, it wants to break this down tokens into much more different tokens, and that is how it kind of looks and feels like it's something that we do as humans. What we do is we take our problems and we stretch them, we make them big, uh, in a way that we can tackle them separately and we can break them down. So this is something that is done by reinforcement learning, and it is the third stage that adds even more high accuracy so that the model starts to think. Can we use it? Are these models available? Definitely. If you go here to ChatGPT, you can see that while you let's go to the next new chat, and here you can see that you have different models available for you. Here you have study and learn. Here you have diff research, which is really the model that actually reasons. In this case, it really reasons deeply because it also does web searches and all that things, which we'll come back to. But there are possibilities to do that. In fact, the best model to show you how this works would be DeepSeek. Uh, but let's just talk about hallucination and thinking model together on DeepSeek right now. So let's say I thought of one quick example. So mm, I would say right now there is this World Cup, Women World Cup, sorry, not Women World Cup, but Indian women team football match going on, right? Indian women's football. So I think the match is with Japan. Okay, the score is definitely not something that good. But the point here is that this is something that is going on live right now. And let's say see the table. Let's see that this team is in the group C. And we can try to ask this to DeepSeek and see if it knows some status about this match. And as we talked earlier, that the pre-training of the model is very costly, and that's why we can't pre-train the model multiple times. So in fact, DeepSeek doesn't let you see when it was pre-trained. Let's type when was this model pre-trained. So we really don't know when was this put. Okay. My knowledge cutoff is May 2025. Wow. Okay, it did answer that. Because the last time when I asked it, it did not answer. So I don't have access to specific pre-training date publicly disclosed. Okay, we can't publicly disclose, but it was May 2025. So definitely this model has no idea about this particular uh, tournament that is going on. So let's ask this model about um, in which group is the Indian women's national football team. Um, okay, I'm not going to write it nicely, but let's say in 2026, right? Let's see what the model says. As of now, the AFC 20 qualifying groups and tournaments draw have not yet been officially announced, obviously, because the model has no idea since it is just trained until the data of May 2025. So the model does not know what's going on. But we for sure know that Our team is in the group C right now, and as you can see, the model has no idea about that, right? But the best part is that the model has not hallucinated here, because now the model, because everyone knows about these issues, hallucination issues, and if uh, the model is not trained on a specific question that it was asked, then usually the model used to hallucinate because it used to act smart, or it used to try to be try to look confident rather, and try to give a plausible solution. But usually that was factually wrong because the model was never trained on that data. But now they have improved this model to say that as of now, uh, actually this is hallucination as well, but at least the model is not giving you the wrong answers, wrong factual answers, but it is giving you an answer based on its when it was trained. So I wouldn't say it's hallucination. Sorry, I'm taking it back, but it's really not up to date. I'm not happy with it because it's not really giving me the answer that I want. But let me use this smart search functionality, let's say. So I'm typing the same question, and now I'm pressing smart search because what it enables is that here you can see that the smart search enables it to search on the internet. And this really gives us power to use the pre-trained model on the current ongoing internet things. Of course, it is not trained on it, but it can search and fetch us some answer. So let's see what will it do now. So it is reading 10 web pages, and I see that the Indian women national team is Group C. Okay, so it has now been able to successfully give us a right answer. Let me ask this question to ChatGPT as well because it would be fun. So when I ask this question directly to ChatGPT, let's see what it answers. So the 2026 AFC ones, okay, it's in Group C, right? So basically, what ChatGPT did, I want to again check that out, is that here you could see sources. So basically, ChatGPT directly used uh, this smart search functionality inside of it. And that is how it gave us an answer based on the current ongoing phenomena. Because in the previous prompt, we asked it when it was pre-trained, and we know that it was trained last year. But now suddenly it was able to give us an answer from this year. So it really means that here it also shows that the sources are so and so forth. So ChatGPT can directly use this particular function, which is basically searching on the web. Now I want to talk about, let's talk about deep thinking. What's happening with deep thinking? Okay, I'm asking the same question, but I'm removing smart search and I'm typing, I'm checking the deep thinking tab here. And I want to see what is really happening, what the model is deep thinking now, let's say. But I want to create a different new context now. I want to just create a new page, new context. I'm into a new tab now and I selected deep thinking. I've pressed enter. Let's see what's happening. See, now the model is thinking. So this is the place where the model is creating even more, uh, you know, tokens out of the token that I have given it to solve a particular problem. So here it says, okay, the user is asking about group of allocations for Indian women's national team. I need to recall or verify the current status. So it is breaking down the question that I've asked into a thinking pattern. So if the tournament is in so and so, I would state clearly, okay, the group stage draws. Okay, the answer is still the same, but at least the model demonstrated that how it can break down this particular question into a bunch of different questions here. So this is really what I mean is that you can add a third next layer on top of your model and make it a thinking model. And a lot of current LLMs, including ChatGPT, DeepSeek, which we just saw, and then also Claude, which we have to come to, they all are capable and they are equipped with this particular facility. Here you can see that also in Claude, I think. Here there are different models. They don't as extended thinking. Wow. So we can also trigger extended thinking in Claude so that it does the same thing and it goes and thinks more. So what I would say is that in this case, if a thinking model is capable to create more tokens, and if it is trained a lot on mathematical and textbook and scientific approaches, then I would use it to ask the questions that require thinking a lot, while also their answer has to be pretty accurate in that case, and there has to be an answer, or else the model will just keep thinking and there will be a lot of hallucination. And that's why whenever I want to solve a coding problem or a mathematical equation or some similar problems, I switch to a thinking model. So whenever there is a problem like that, whenever I have a math or a code that I want to debug or solve, not always, but a lot of times I switch to a deep thinking mode so that I can enable thinking and I can enable solving that problem in a more scientific, in a manner that you can break down the problem into small chunks and then flow through them. Knowledge of self is the third interesting property of this model. So how does the model knows that it's ChatGPT or whatever? So for example, let's ask ChatGPT, um, what is your name? Right. So what is the knowledge of self that this model has? So this is my name is ChatGPT. You can think of me as an AI assistant and so and so. Uh, so the usually the knowledge of self is not on the internet data. So this is something that was really uh, created. Okay, so actually this description is not right, but the actual description is that it is just uh, uh, part of the post training data basically. So we have just teach the model to give this answer whenever people ask them about whenever people ask questions about itself, right? So this is not really part of training data, but it's more of post training data where we fine tune these models. All right, so now we know about pre training, we know about post training, and we also know about thinking models. We know about there is a third layer, uh, which is thinking models. I think now is the right time for us to also talk about some of the limitations of these models and then go to talk about how we can use these models, right? So since we know that these are just token tumblers, these are just models that are predicting the next word, they're not really, this does not make them good in math, right? In this case, in the first question, when we asked, for example, in this case, we asked 2 plus 2 equals 4 was our answer. That was not necessarily because this model calculated 2 plus 2, but it has seen this sentence a lot on the internet data, and now it loosely recollects what should come next. And that's why it gave that answer. But the model has not really learned to do math by itself, right? Because it's a language model, it is just trying to predict the next word. And that's why it has so many problems while dealing with mathematics as such. So here there is this feedback developers to the developers of OpenAI, and there are many people who have a bunch of questions and problems here. Here, someone is saying that ChatGPT gives calculation error. We have a problem with basic maths. So see, there are so many points, but of course these are pretty old activities. But there are from 2024. Then there are a lot of new, rather, how I would say, complaints is the right thing, because on this place people complain about ChatGPT not giving the right answer. So in this case, on July 2024, someone asked ChatGPT to compare 9.9 and 9.11 uh, mathematically, and GPT said that uh, 9.99 is smaller than 9.11. But this is not really math. But the idea here is that the model is not great at doing things like that, comparisons, calculations, or logic as such. Here, there are many related topics which talk about why these models are bad at math. Because these are really not the models trained to do math, but they are really trained to just predict the next word, uh, right? So that's why I would not use it for doing math. But if I want to do math with it, then what I'll do is, and what you should also try to do is, let's say we want to calculate x from when when 2x is equal to, okay, a very easy problem. When 2x is equal to 38, what is the x? What is the value of x? In this case, what I'll just say is that to the model is use code. So the code here is basically Python interpreter tool that the model can call from inside, and that is when it uses Python, which is a programming language, as its calculator, and then calculates this particular operation. Actually, this is a pretty simple task which you can directly do with ChatGPT itself. But I'm just trying to put the idea that whenever you see or whenever you have a mathematical problem, it is not the best thing that you communicate that to ChatGPT directly and rely on its answer directly. The best thing would be to actually ask the model to use something like a code, which means that the model will then open a calculator. In this case, it's used an instrument, which is the calculator. Or sometimes, if the question is too big, then it will use a Python interpreter to really give an answer. And I think this would be a logical way to do math. So that's why I would not recommend you to do directly math on the lang on the chat, but you can use something like a calculator, or you can use code, or you can hint the model to use code. Um, all right, I think I want to quickly go through the next slides because I have a lot actually to say, and we are running out of time. Uh, but now that we are on how to use these models, here is an idea of how these models see whatever we say. So whenever I'm in ChatGPT, let's say, whenever I hit new chat, there is a new context window that opens. So here, the blue one, as you see in the background here, so this is the context window. There is nothing inside right now. But as soon as you type something, so this green is my question, this is me, I've typed something. So I typed here, why is the sky blue, right? That was my question. So the model converts into tokens. And then these tokens, and the model responds into tokens. And the response is, of course, then also converted into human language, and it gives me a language. But then I ask the model another question. Okay, then what do you mean by, let's say, scattering of light? Because that's why the sky is blue. So I asked the model, what do you mean by scattering of light? And then it gives me another big answer, big chunk of an answer. What actually is happening, if you see carefully, is that our context window, the blue window, in this case, which is completely blank right now because I haven't asked anything to the ChatGPT model. But here, since I have asked it already few questions, it has also given me few answers. So our context window is filling up. Our context window is getting more enriched with the with the answer that I want. And this is what is happening. So basically, this is what we call as context window. Context window is wherever a user and the model has had a chat, and there is some build up that is happening. That is called as context window. So whenever I say that uh, so the context window is blue in this color. So whenever I say the context window has been is almost full, that really means that we have had a lot of talk in this particular context. And what actually is happening is that the model starts to forget what we have talked earlier, some key elements there. And that's why it's really nice and smart to plan and communicate in proper ideas what exactly you want from the model. So it's not a good idea for me to talk to model on some things that are not really relevant to the answer that I'm seeking, for example, in this case. And of course, it's also not smart to use the same context window for a different answer as well, because this context window is already full. So I can't really ask a different question. Right now, I asked a question why the sky is blue. I can't now ask a question where the cat is sitting, right? I can do that, but that's not smart to do because the context window already has the context that you have talked of, and you should use this space or this particular window very smartly to really get most out of your answers from these particular systems or these particular models. Um, but this context window can only give you an answer in text right now. It can't give you, as I said, it can't calculate math for you. It will use a different tool to calculate math. In our case, when we asked ChatGPT to do math, it used calculator, as you saw. It can also use code, but it also ChatGPT now can use internet browser, but it is not really the task of the LLM. But in this case, LLM is triggering to new uh, tools that are in its arsenal right now. Python interpreter and everything is not really part of context window at this point, but we can definitely use it. So what we understand with this context window is that, firstly, what we understand with this knowledge is that when we go to this model, everything that is inside of this model, the parameters or the internet knowledge, is really loosely packed knowledge, right? We talked about it. It's really vague recollection of internet somehow. So that's why knowledge inside the parameters basically are these inside the model, is nothing but a vague recollection of the internet. But the knowledge in the tokens, which are these places inside the context window, are really the working memory. So you have to think about how can you use this working memory in the most wise way. Let's put it that way, uh, because you don't want to load it with something that is of not interest to a particular solution that you are seeking. So you have to use this space very wisely. What happens if the context window is too long um, and non-efficient? The results cost higher because sometimes the focus is degraded because you have asked something very critical, but if the context window just expands with also non-efficient context with something that is here and there but not really on point, then you really degrade the focus of the model, because the working memory is something that you should definitely think of critically and use it pretty nicely. uh, that's why what I do is whenever I have a different question to ask, whenever I have a new question to ask, you have seen me hitting a new chat because I want my context window to be clear completely. And that is where I start it as a blank new space. So whenever you are using ChatGPT and whenever you have a topic that are not related to each other, but you want to still ask, go ahead and hit a new chat function so that you have an open free context window, and there is not much in your working memory, and you have a clear space then to experiment or ask questions. Now, with this, it's also evident that these models don't remember anything. So it's really strange for me to ask this model that remember on on the August of 2025, we talked about so and so. I think this doesn't make sense because, as you see, the working memory is new all the time. Whenever we hit new chat, there is a new context that is created. So these models are not humans like we are. We remember. Okay, I remember when I've had a good when I was hiking with my friend, let's say on August 2025. I remember and I can recollect and talk to it about my friends. But these treat these systems or these machines as something that are just an instance of a body of a particular training data set. And whenever you hit a new chat, you create a new instance. The genie appears. Every time the genie appears, it's a new genie. So the genie has no idea about what you have asked it before, and it just comes and gives you new answers. And that's why you have to treat it in a way that this is a different context and ask questions wisely so that you can save a lot of time in the a lot of space in your context. From there, now, what happens with context and thinking models? Obviously, because thinking models produce more tokens, as we know. We talked about that thinking models break problem into more sub problems, and then try to solve it. So that's why these thinking models use even more tokens. So if you are using a thinking model, then of course you have to also know that they are going to use even more tokens, which is actually nice because it captures a lot of nuances. They are trying to find a lot of nuances and a lot of details in your question. But you have to also know that your token space has now expanded. So you can't just keep asking a thinking model different questions or non-efficient questions, because then your context window just get flooded and the focus is moved from the solution. We talked about context. How can a model become a thinking model? So here you see that my model has a thinking cloud here. We talked about this, so I don't want to go back to this. But I think that these type of models, I use them for better problems in math and code. Whenever I have difficulties in understanding some mathematics or code, then I try to use thinking models because it breaks me down the problem and it makes things very simple for me. And I use all the non-thinking models, which we just talked about, like ChatGPT, Claude, and they're non-thinking alternatives in this. This, for example, in ChatGPT 5.3, I don't think is a thinking model, but 5.4 is a thinking model. So for simple questions, for writing my emails, for just general questions about the internet or about the world, or some general questions, I just use non-thinking models because they are fast and they don't fill up the context uh, space that much. Um, Tokens are expensive. Obviously, there are a lot of models where you have limited token size. If so, whenever you pay for ChatGPT or Claude, they will say you always that there is this much tokens that we offer on our paid versions. So think of tokens as something as expensive. Also, context space. When we talk about context window, that is also something that is expensive because you have to use it wisely to get your work done. Um, if there is too much into your working memory is too loaded, then the model will get distracted, so you have to be on point. Don't overload it with unwanted information. As I've said, a good context window should start like this. um, but there is also some new techniques that people are researching right now. And since we don't have much time in this session, I won't talk about it. But the idea is that you can also compact your context so that you can use this previous context into a new window and then start talking about this as well for your future conversations about the same topic. Um, with this, I just want to quickly show you some tools that are possible to be used with ChatGPT, with Claude, and with a bunch of other LLMs as well, but especially with Claude, I like these tools, and also ChatGPT is pretty straightforward. And how can you use in using these tools? So here you see, as I said, for math, I would use code. Whenever I have a math problem, I type that problem and I try that to use code. So our ChatGPT is now enhanced with a toolbox, or our LLM model is enhanced. LLM assistance is enhanced with a toolbox. Um, I also use internet search, which we actually did, right? In this case, in our previous conversation, actually, we actually used internet search to find out what's going on with Indian women's football team at this point, right? We saw which group they are part of. So internet search is to give the model the knowledge of today so that the model can also answer us about the things that are happening today. It can perform searches, it can put, and what actually happens is that it goes to internet, it searches for the today's problems or today's event, and it puts it all into its context window. So so this is the context window, right? So the model fills up the context window with the things that it has found on internet, and based on that, it then since it's feeded in our context window, so it's part of our working memory, and then you can ask it questions or you can really get answers on this particular working memory as well. So that is what actually is happening in this case. Whenever we use internet search, it searches, it fills up the context window. Deep search, deep research is actually really interesting, and it's triggered by a special token as well. So what actually happens is that when you type something here, let's say why the sky is blue, we'll again stick to the simple question that we had. And when you enter, you can actually use a lot of options here. One could be deep research. So here you choose deep research. And now what will actually happen is that you will have the internet search toolbox with a thinking model. So now the model will not just search internet based on your prompt, but it will also think. It will create more different tokens, and it will try to search everything that around the context that you have built in its working memory. So that is what really gives you more power. And I would use this type of tool to search for literature, let's say, or to talk about some some interesting, difficult scientific problem or mathematical problem. That is when I would like to use such tool, which also has thinking capacity of an LLM, but is also equipped with internet search. Uh, I think it's very powerful, and I would definitely say, definitely would say you all to use it for your research to find books, to find literature, and to find a lot of solutions. You should definitely go ahead and use deep search. As I said, it combines internet search and it combines that thinking model that we talked about. The other tools that I use here, I have loaded actually something into the ChatGPT framework, but I haven't yet tried it. So what I actually did is I searched for this. I have read this article, which is called "How India's Caste System Limits Diversity in Science in 6 Charts." So how caste system really affects the sciences in India, which is a serious problem altogether. So here I downloaded a PDF of it. I see that it's not really in a good print as of now, but I downloaded the PDF because I've read this. And what I did is I fed it to ChatGPT. And now I'm just going to ask it to, can you please summarize this article for me? Okay, I've done that. And now what actually ChatGPT is doing is that it is taking this file because we can upload files to it, and this is one of the tools. So what it does, this file is uploaded. But interestingly, when the file is uploaded, all of the data inside this file, all of the things that you see here, the written data especially, not the images. The images, I think, as of now, are not really looked into it, so they are probably skipped. But all the text data in the file is loaded into the context window of the model. So now the file is uploaded, and it is the text from the file is fed inside the context window of the model. So now the working memory of the chat that I am inside will have this complete text inside of it as well. So this is really powerful. And now what I did is after uploading, I have asked to the GPT from its working memory that can you please summarize this article for me? So here it did. It did that. Okay. Um, here is a clear structured summary of the article. This is the name of the article because it's inside the context window of the model right now. And what it does is it says that the article argues strongly influence who becomes a scientist. Exactly, caste system strongly influences that. Um, then it gives you some data here. Uh, then it talks about some patterns that it has found. And Dalits and Adivasis are already underrepresented in STEM fields, though uh, less so in arts as well. So it has given me a quick summary of what the document is about. Now, what I can also do is that I can also ask it questions based on these documents. I can also go to a specific uh, place, let's say funding mismatch. And I can also ask it that can you please elaborate on funding mismatch? I don't want to do that because of our time constraints, but I can ask it, can you elaborate on, did I copy it? Yes, I copied it. So funding mismatch. All right. And you know what? I can also say it, can you as well find similar uh, papers or cases? And whenever I ask this question, now as you know that this complete PDF is inside the context window of ChatGPT, it uses that to also find new things. And now I want the model to do web search, let's say. I don't want it to do deep search because it's fine. I have already filled up my context enough for the model to know what to do. So I don't want to use deep search now, but I'll use web search and I'll hit an enter. And that is when the model will first give me this answer, obviously. But then the model will also try to find answers based on the context that is fed to it. And in this case, as you see, I have not wrote anything, but I've just uploaded a file and the model has figured out what the context there is. Because now this complete file and its text data is inside our context window. So this is a great tool to use to read books and articles because you can translate them into your language. I can write the model to write this particular complete PDF into Marathi, for example. If I'm more comfortable in Marathi, I can say the model to summarize this article in Marathi. Let's try that. Summarize this article in Marathi. Because now this article is part of the context window. So I think the model has to now figure out how can it summarize. Okay, I did a mistake because I hit web search, if you saw that, because the search was clicked, but it's still fine because I don't think the model needed to search. The model only searched Nature, which is really the publication body of this particular uh, article. So here the model was successfully, as I said, there are chances the model can hallucinate. So you have to really read through it before you use it anywhere. You have to read the article. First, I would say you read the summary. If you think it's interesting, say the model, where do you find so and so, and then you can also go into the article to specifically read a particular point that you agree or disagree to. uh, so this is really interesting. Now we converted the context window into Marathi, and now we also have some Marathi ideas here. You can also type in Marathi more questions about this particular document. uh, the last tool that I use often is Python interpreter, where you really create programs, Python programs. You can solve functions, you can solve mathematical problems inside of this. But you can also use it locally, or you can create your own projects, applications, and a lot of other things. What I feel is that, in my personal opinion, I have found Claude performing wonderfully well. Uh, okay, not this. Going back to the page. So, in my experience, I've found that Claude performs wonderfully well for these particular tasks. So, whenever I want to create an app, or whenever I want to create a program or a mathematical visualization, let's say, or something like that, that is when I always think of Claude. Uh, and I don't think of ChatGPT in that case. And that's why I would highly say you, based on my experience, if you want to write good computer programs uh, as of now, then I think Claude is doing really nice. And that's the reason I've just wrote this very small, um, before the start of today's session, I wrote this pretty small, what we call that, prompt. I tried bunch of others, and I chose one nice one. And I wrote this prompt, which was, "Can you create flashcard game on Savitribai Phule, life, achievements, greatness, etc." Very simple prompt. The Claude understood it. It, of course, created it into HTML, so it created the code for this particular app, or app inside HTML. And here you could see that. So whenever you click this particular window, the 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 visualizer actually pops up, and here you see how the app looks like. So it looks really nice. I think so. Like, there is the Savitribai Phule name, and then pioneer, poet, revolutionary, the uh, key points here. Then it's, of course, the date, their date of birth, and then some of the facts of their early life. For example, let's go through something. Okay, what was Satyashodak Samaj, and what role did Savitribai play in it? And when you turn it, you see that Satyashodak Samaj, which is also which translates to Truth Seeker Society, was founded by Jyotirao Phule, Mahatma Phule, obviously, in 1873 to challenge caste oppression. Savitribai was an integral leader. She conducted Satyashodak marriages, which were caste-free, without dowry, and performed without Brahmin priests. So whenever you understand an answer and you have read it, and if you now feel that, okay, I'm confident about this particular question and answer, then I can hit, I got it. And when you hit got it, you complete all the levels. And there are about 22 questions. And when you do that, you get these stars upon finishing this particular question set. And all this was just done by one single prompt inside Claude. So right now I'm using Claude, uh, which I feel, as I've said, is very powerful to create programs, to create applications, to also do mathematics. And this is one example of how you can create an application inside Claude with just one simple prompt. So these are the tools that I use, and these are the tools that are equipped with our LLM assistants as a toolbox. So these are not different models; these are just toolbox that the LLM can use to solve certain problems, and they are all triggered with different tokens. So whenever LLM sees that the individual has asked me to do a particular thing, it can trigger these tools from its toolbox with a particular token. And I think, yeah, these are the tools that I use. I am sure that there are even more that uh, someone from you might be using, or there are some more interesting things that you all would be doing with these tools. But these are the ones that I use in my day-to-day life. Now we are almost at the end. I see that the session got extended a lot, and I've been talking forever. But coming to the end, what we have realized is that context is very important. Even for us to guess the next word, we need context. So that's why context is important, situation is important uh, for for us to really dictate the context. Then data is important, task is important for even us to understand what's going on. Similarly, I believe that this is also a nice way to prompt your ChatGPT or your Claude structure. So you have to give it a context first. So context could be about you. You can say that I am, for example, I am a marketing manager at a B2B company. I do so and so forth. Then you can say, Claude, about a situation that you have, or to ChatGPT in this case, in the next para. Then after you have talked about your situation, you can talk about the data that is available to you and the problem, right? You have a problem and you have some data, so you can talk about that data here and give it more details. And then you can exactly ask it precisely what you exactly want out of, what help you want out of this particular model. I think this is a nice way to structure um, a prompt inside ChatGPT or Claude or any LLM as such. So you can start with context, you can then give a situation and then data, and obviously uh, be precise at your task. I think this is a nice way to use the context window or the working memory properly, because with the context, the model directly hits to the point in its uh, loosely packed internet data. It directly recalls the exact things that you are going to be building on top of eventually. The prompts that are going to be built are stacked on top of, let's say. So context is really important. It is the bedrock of what you are going to discuss with the model in the future. And that's why I think that you should give context as the first thing, situation as the next thing, and then data and task. So this is a prompt idea that I use. I remember it as CSDT, and I just write my prompt based on this. And I separate it with paragraphs, for example, often. So this could be one way to use these models as a prompt. And then coming to the last slide, the 15th slide, the last one. I know we have spoke a lot of things in this particular session. I am sure we went from different sites to different topics to different ideas. Um, and I know it can be overwhelming at times, because it was in fact overwhelming for me to really present all of it together in one particular session. Um, we have still not talked about a lot of things. We have still focused on what's important, but let's come back to some key takeaways and then finish this session, and we can start with our Q&A. So key takeaways here: LLM, ChatGPT, like ChatGPT, Claude, or whatever, is a lossy internet zip file, as I've said. It loosely recollects or recalls data from internet. It's not a final answer machine. If you type something, if you ask something in ChatGPT or Claude, and you expect to get a final answer, you get you expect to get an answer that's an actual factual uh, answer, then that's not the case. It's a lossy internet zip. Next thing that we learned is that context window matters, because the context window is really the working memory of our model. So I would always use a new context window to write a new question that is not related to the earlier discussions in this case. Use context window wisely. Of course, hallucination, which is model giving wrong answers confidently, is very common and can happen. That's why you have to read through your answer properly and cross check it. But hallucination is more likely at the edges of knowledge. It more likely happens at the places where the model has not been trained, right? For example, one such knowledge is about the current situation in the world, because the model was not trained on today's data, right? It was trained in 2025. So on such questions, there is a high chance that the model will hallucinate. It is better to first set the context before asking your question, as I've said. In our table here, I see that it's really interesting, and it's really important to first set the context so that the model can properly assist you. Um, and I use thinking models to ask tasks that require thinking for a verifiable right answer. Obviously, there has to be a right answer, or else the model just keeps thinking and eventually hallucinates. So that's why I would say I would use a thinking model for coding, for math, for arguments that to prove a certain thing. So in that case, I use thinking models. Normal models I use for email, brainstorming, general questions. For serious task, I will load context window with as much as critical possible context. So here I thought I see this as a serious task, and that's why I loaded a context window inside of this as a file type. So what I would do is if I have a serious problem, or if I have and a startup that I'm building, or if I have an app that I'm creating, and I want genuine help from these models that help from these models that would genuinely help me, then I would feed in as much as critical context possible, which is really important, and not anything that is not that important. So I'll only look into the critical important features or context, and I'll feed that to the model. Um, with this, I'm ending my extended talk for today. I'm open to receive any questions. If you want me to revisit any slides, then I'm more than happy to also talk about them. The point is, use LLM in your day-to-day life. Use the tools that they offer, which we talked about briefly. Um, and we also talked about how easy it is to now create apps, or to practice some, um, or to learn new things with these types of LLM models. So I would highly encourage every one of you to use them, and to revisit this talk, or to ask me questions. And you can also critically, examine these models, and then come back to us and ask your questions about these. So with this, I would like to end my talk, and I would welcome you, or invite you to ask more questions on the presentations that I did today, um, and the things that we discussed. So thank you, everyone.